Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about how to figure out the density of some sand and some methanol mixed in a graduated cylinder when they're mixed together, and you got to figure out what the densities are and the volumes and things like that. So let's get into this. So here's the problem. You got a student who weighs an empty 100 milliliter graduated cylinder. Then what she does is then she fills the graduated cylinder with 15.0 milliliters of sand. They fill it with sand up till the mark. So she has, when she reads her graduated cylinder, it reads 15.0 milliliters with the sand alone. And then she weighs it again, and she gets the mass of that with the sand in it. Next, she uses a pipette and transfers 15 milliliters of the methanol. So she's using a 15 milliliter pipette. That's important to understand. 15 milliliter pipette. And so she's transferring over exactly 15.00 milliliters of the methanol to the graduated cylinder. And then she stirs the sand methanol mixture until no bubbles are left, or the bubbles no longer emerge, and the sand looks uniformly wet. Okay? Then she records the final mass with the cylinder, the methanol, and the sand in it. And then she has the data, right? So then what we're going to do is we're going to use the data. So here's the data. Here's the masses, mass of the empty cylinder, mass of the cylinder and the dry sand together. And then here's the cylinder plus the wet sand, which means that it's the cylinder plus the methanol plus the sand. Okay. And then here's the volumes of the substances. So the volume of the dry sand was 15.0 milliliters in the graduated cylinder. The volume of the methanol that was added using a 15 milliliter pipette to the graduated cylinder, well, obviously that's 15.00 milliliters because she used that pipette to measure and transfer to the cylinder. And then the volume of the sand plus the methanol in the graduated cylinder turns out to be 26.4 milliliters. So using this data, we're being asked to do the following. So A, calculate the density or determine the density of the dry sand. B, determine the density of the methanol. C, determine the density of the sand particles. So yes, the density of the dry sand and the density of the sand particles are not the same thing. They're different. And then D, does the bubbling indicate a chemical reaction between the methanol and the sand? And we'll talk about that in a moment. So first, we got to calculate densities. So the thing to remember about density is the density formula. So I'll write this up here. So density is equal to mass over volume. Mass over volume. Okay? So if you know the mass of your substance and you know the volume of the substance, just divide the two and you get the density. But the hard part is finding the mass and density, or maybe it's not that hard. We'll see. Okay, so first, find the density of the dry sand. So to find the density of the dry sand, notice we have the mass of the empty cylinder, 24.8768 grams. And we have the mass of the cylinder plus the dry sand, 46.6525 grams. We can find the mass of the dry sand by subtracting out the mass of the cylinder. Since this is the cylinder and the dry sand, subtract out the cylinder and you get what's left is the mass of the dry sand. So let's go ahead and do that. So it's going to be, where are we at? So 46.6525 grams minus 24.8768 grams. And when you subtract that, you should get the mass of the dry sand, and we do get 21.7757. So 21.7757 grams. Let me double check that. 21.7757. Yes. So now we have the mass of the dry sand. Now all we need is the volume. Well, looky here. We have the volume of the dry sand, 15 milliliters. So now to find the density, we just take the mass, which is 21.7757 grams, divided by the volume, which is 15.0. 15.0 milliliters. Okay? So now all we have to do to calculate that. But before we calculate, we should identify sig figs. So here we are subtracting. So remember, the rule when you're subtracting or adding is that your answer should have the same number of decimal places as the least number of decimal places in the measurements that you are adding or subtracting. And so here I have 1, 2, 3, 4 decimal places. Here I have 1, 2, 3, 4 decimal places. So my answer should have 4 decimal places. 1, 2, 3, 4 decimal places. So we're good. Okay, so oops. Sorry about that. So now that we have our grams in the right number of sig figs, and of course the sig figs with regard to the volume, since we're given a graduated cylinder, they're giving us the measurement. So all of these are significant since we haven't really done anything with this number. So this is our measurement. And so when we divide this all to get the density, we should then keep track, because here, when we're looking at significant figures, the answer should have the same number of sig figs as the least number of sig figs, not decimal points, not decimal places, but sig figs. So here we have 3 sig figs. Here we have 6. 3 is less than 6, so we're going to have 3 sig figs in our answer. And when we do the calculation, we get 1.45. 1.45 grams per milliliter. And that is the density of the dry sand. So I'll put that up here. So that'll be 1.45 grams per milliliter. Okay, now next we have the density of methanol. So same thing, find the mass of the methanol, find the volume of the methanol, divide those together. So do we have the mass of the methanol? Well, remember, here we have that cylinder plus the wet sand is 58.5325. Well, if we could subtract from that, now wet sand means the methanol plus the sand. So here, as everything, if we can subtract out the cylinder plus the dry sand, right, we got that together in this amount, we could subtract this from this, and what we'll have left is the methanol. So just subtract these two, and you've got the mass of your methanol. And when we do that, let's do that. Go ahead. So we have 46.6525 grams. I'm sorry, I'm doing it the wrong way. I want the 53.25. So I'm going to have 58 0.5325 grams. That's with everything together, your cylinder, your methanol, your sand. But we want to subtract out the sand and the cylinder, so that's this mass here. So we're going to subtract out 46.6525 grams. And when we subtract those two, we get 11.88. Okay. 11.88. So let me double check that. And that is indeed what it is. Now, the thing to keep in mind is, again, when you add and subtract, your answer should have the same number of decimal places as the least number of decimal places in your measurements. So here we have 4 decimal places, here we have 4 decimal places, but here we have 2. So in this case, we have to add 2 zeros to the end, and so that's going to be grams. So now our answer has 4 decimal places, just like this. So the least number. Okay, so now that we have our mass, now all we need to do is divide by the volume. And the volume, again, we're looking at methanol. So the volume of methanol was given here, right? We took our pipette. It was a 15 milliliter pipette. So that's the volume. So to get the density, all we do is take the mass divided by the volume. And so when we do that, density is equal to 11.8800 divided by 15.00 equals. And so again, here when we're doing our figuring out our significant figures in our answer, we're looking at the significant figures. So our answer should have the same number of sig figs as the least number of sig figs in our measurements. So this is grams, and this is milliliters. So we have 4 sig figs here. We have 6 sig figs here. 4 is the smaller one. So our answer should have 4 sig figs. So when we calculate this out, we get 0.7920. 0.7920 grams per milliliter. So this is the density of just the sand. This is the density of the methanol. So far, so good? Okay, so now we want to find the density of the sand particles. Sand particles. So remember, we added sand to the graduated cylinder first. Now, is the sand going to occupy every nook and cranny, every possible space, even the space between the sand particles? No, there's going to be space that's filled with air in between the particles. So there's that open space. So there are open spaces that the particles themselves are not going to occupy in the graduated cylinder. So this 15 milliliters of sand that we filled up in the graduated cylinder, the sand grains aren't filling up all of that space. A lot of that space is going to be filled up with air, right? Or maybe not a lot, but some of that space is filled up with air. So what we need to do is find only the space that was occupied by the sand particles themselves. Now this is where the volume, the total volume, and the volume of the methanol is going to help us here. Because remember, we put methanol into the graduated cylinder with the sand. Okay, so that methanol is going to occupy the space between the particles where the air was once filling up. So instead of air now filling those spaces, the methanol is now going to be filling up those spaces. And so what we can do now is we can find the volume of only the particles themselves. How can you do that? Well, since we have the volume of the sand plus the methanol, that's 26.4 degrees, 26.4 milliliters. Well, we know the volume of the methanol that was measured by the pipette, that's 15 milliliters there. So if we subtract the 15 milliliters of the methanol from the sand plus the methanol, then the leftover volume has to be what's occupied by just the sand particles themselves. Okay, so let's go ahead and find that. So I'm going to go ahead and erase this, or I'll keep that. I got some space here. So in the space here, I'll find the volume. So we have 26.4 milliliters. So right here, 26.4 milliliters is the total. We're going to subtract out the 15.00. And when we do that, what do we get? We get 11.40. 11.40 milliliters. Now, when we subtract, again, the answer should have the same number of decimal places as the measure with the least number of decimal places, right? So then this has 1 decimal place, this has 2, so 1 is less than 2, so our answer should only have 1 decimal place. So I'm going to put an underline there to remind myself that this is the last significant figure. You can keep the 0 if you want. Usually you would keep 1 extra digit if you are going to use this value further in calculations, which we are. So let's just go ahead and keep the digit. Okay, so this is the volume that is occupied only by the sand pebbles or the sand particles. Okay, well, what's the mass of the sand particles? Well, we already have the mass of the sand particles. We saw that before. So right here. So we have the mass of the sand particles here. So all we have to do is divide the mass by the volume. And so let's go ahead and do that. And let's see, do I have space here? Yeah, I have space here. So I'm going to take the mass that I had before. So this is the mass of just the sand particles, the dry sand. So that's going to be 21.7757 grams. I'm going to divide that by 11.40. Again, I'm going to underline the 4 to remind myself that's the last significant figure. Here I have 6 significant figures. Again, so when I divide these two numbers, my answer here should have the same number of sig figs as the least number. Since 3 is smaller than 6, 3 is the number of sig figs you should have. When we divide this, we get 1.91 grams per milliliter. So that, ladies and gentlemen, is the density of just the sand particles. Okay, so we've got our density. Last question. Does the bubbling indicate a chemical reaction between the sand and the methanol? I'm hoping you probably figured it out by the time we got to this part in the video, because I did kind of mention a key thing that happened. So remember, when you add the methanol, right, before adding the methanol, what did you have filling in the spaces between the particles? Air, right? If you put in the methanol is going to then replace the air and fill in those spaces. Well, notice that here, what happened? What does she do? She stirs the sand methanol mixture until bubbles no longer emerge. Why is she mixing it? The reason she's mixing it is to get the methanol to seep through and push out the air and basically replace the air by filling in the. So you're replacing the air that was in between the particles with methanol. So when you're stirring it, the bubbles don't indicate a chemical reaction. They indicate that the methanol is pushing the air out and the bubbles is just the air coming out. And you don't want the air in there because, again, you want to figure out accurately what the volume is of the particles themselves. And in order to do that, you need the methanol to pull out all the air and don't let the air take up any volume. And that's the answer to that question. I hope this was helpful. I hope you enjoyed this video. If this was helpful in any way, then please like the video, share the video, hit that like button over there somewhere around here. I don't know, maybe they moved it. Also, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a question or a problem you need help with, put it down below. I would love to help you with that. Thanks for joining me and have a great day.